Thanks, everybody. Can everybody hear me? Yeah, in the back? Cool. Okay, so my talk's about cross-site scripting in relative URLs and some other techniques. So I'm a researcher for Portswigger, makers of Burp. I've been working there for a few months now. I'm a JavaScript XSS hacker. I love anything JavaScript and XSS, obviously. I love JavaScript sandboxes too. I've got a project called Mental.js, which sandboxes JavaScript into safe form so that you can inject JavaScript itself and rewrite the entire page and intercept any XSS and rewrite it into sandbox JavaScript. Check it out, it's called Mental.js. I worked for Microsoft for 5 years testing the IE XSS filter. So if you find it hard to bypass, hopefully you do. That's because I've been testing it. I just had this slide because I wanted to put a zombie on my slide, so basically. So we've got zombies in security and in horror films. There's lame horror films and there's endless sequels. I Know What You Did Last Summer. I Still Know What You Did Last Summer. It can all apply to security. I'll always know what you did last summer. I can't believe that. Endless. We've also got some lame vulnerabilities and lame films. Tab jacking. So the Saw moment is something that is an unexpected twist. If you've seen the film, it's quite a good twist in the film, and it applies to how I found this vulnerability. I was thinking outside the box, trying to think of a way to exploit something that I knew was a vulnerability, but I wasn't sure how to exploit it. So it's a clever thing they didn't see coming, and people might have seen the functionality, well, the behaviour, should I say, but nobody thought a way of exploiting it. So yeah, you enjoy it, and afterwards you think, oh yeah, that explains a lot. And basically, absolute URLs. So absolute URLs are complete. They specify the full URL and parses the protocol. There's no guesswork involved for the browser other than resolving the protocol. But relative URLs, now that's different. Relative URLs, depending where you are in the structure of the site, so you can say .. You can go in the document, but there's something not quite right about that. The browser gets you where it thinks you are in the document. So the server knows the file, but the browser has no idea. So there's guesswork for the browser. So I consider relative URLs harmful, and I'll show you why. So have you visited a site and see all the CSS disappear? Usually, if you put a / in the URL while you're pen testing a website, for example, you'll see the CSS disappear. Something isn't right, and I wondered why. Why was that happening? So I looked at Firebug, looked at the requests, and the behaviour when you put a / in the file name was different. The CSS disappeared. The CSS might return a 404 or a 302. So the relative path can reference a style sheet. So if you add the / to the URL, it doesn't expect the site doesn't expect you to insert a /, and therefore it resolves the CSS file in a different way. So it finds it at a different location. What's interesting is it either returns a 404 or a 302. Now a 302 you might not notice because, and you might wonder why it's returning a 302 if you put a / in, because surely it can't find the file. So has anybody developed a website with a relative CSS URL like that? Hands up, anybody? Yeah, only that many. I thought it'd be more than that. So your code could be vulnerable. So if you add the slash, the URL is changing. The expected URL is provided. So the URL that you're going to get is different than what it's expecting. So what happens is you go to the relative URL is parsed, but it's actually it's actually executed on the injected page. So the CSS file is actually going to the HTML page instead of a CSS file. So RPO is relative path overwrite. That's what I've named the technique, and it works with CSS, but it works in other areas as well. I call it RPO. So you need some persistent text on the page, such, for example, username, a mail subject header or something like that. You need a relative path that references a style sheet, and the browser will render the style sheet and execute the code. So it will look for the CSS file that you've specified, but it will actually execute on the HTML page, and the persistent text that you've entered will be executed, and it works on IE, obviously. So to understand how to exploit it, you need a quick CSS lesson. So what's interesting about the specification, I think it's in CSS 2.1. The user agents must ignore the style sheet when it ignore the styles when it encounters an invalid rule. So maybe we can take advantage of that by ending a CSS selector and then executing the CSS. So if we can get the browser to point to a web page and it contains CSS, maybe we can render it. So using a CSS selector, you can make it ignore what's happened before. So if the relative URL is being sent to a web page and it encounters HTML, you can make it ignore the HTML code, which the browser thinks is CSS. Expressions are our friend. Basically, expressions were just created for pen testers. So the web page contains a relative URL. So the shortest vector in the world is just a /. So when the / is appended onto the URL, the relative path is changed so that the relative URL is changed to point to the HTML. The style sheet it's loaded as CSS, and what you'll see if you look at the network, you'll see it pointing to. Sorry about that. You'll see it pointing to the / web page, and then it'll look for the CSS within the web page. So you need rewrite rules enabled, or in ASP you might. I think ASP.NET by default supports pretty URLs. So you'll need a pretty URL as it's called. And so what's happening is that you're not actually referencing styles.css, but you're referencing the PHP file. So this is how it works. So that can everybody see? So basically, you close the CSS selector, it injects in a global rule, it executes the expression. The relative style sheet is loaded, and the loads the whole page, and you just inject a / with whatever URL you want. So .. What if somebody put a .. in? Could you exploit that? Luckily, you're safe. Actually, not you. I'll lie. RPO2. So the browser comes up. So if you enter .. in a relative URL, it looks upwards in the directory tree, obviously, but the browser doesn't know what the file is. Only the server knows what the file is. So if we provide a fake directory, then we can send the URL back to itself again. for example, /v directory, whatever. So then the style sheet is then loaded back onto itself again. Well, not itself, the web page, the parent web page. And expressions work in IE compat mode, but not in Spartan. You can use iframes to downgrade the website and execute expressions. Next part of my talk is about mutation XSS. Me and Mario came up with the name. So it happens when HTML mutates from a safe state, from a safe state to an unsafe state. So you might have a perfectly valid HTML fragment that looks safe and is safe, but when the inner HTML is read and written, it's mutated into an unsafe state. So we're basically fooling the actual HTML parser to rewrite the code. And there's many ways to do this. Attribute quotes, XHTML, HTML confusion, and CSS strings, URL badly decoded and stuff. All happens on IE. So there's the classic vector that Yusuke Hasegawa came up with. So basically you've got an image element, and in the title there's two backticks, and when it's rewritten, when inner HTML is read and then written, it gets rewritten and the on-error handler gets executed. It was previously in the title attribute. Yusuke Hasegawa discovered it, and he's the birth of, he discovered mutation XSS, basically this is the birth of it. It did work in IE7, but now it's patched, unfortunately. So maybe we can confuse the parser with XHTML-like vectors in HTML. So maybe we can confuse it into thinking it's still inside an attribute and then therefore render entities. So for example, XMP tag, this is the valid string that isn't malicious, basically. And notice the / on the end of the element name. When that's rewritten, the source code gets parsed, the entities get parsed, it closes the XMP tag and executes the iframe. And that works in IE9 compat mode. You can also use the same in styles, script, comment, XML. So this is an example with style. So when inner HTML is read and written, they'll get mutated. So another tag that mutates is the in IE, it's a HTML like comment tag. It's sort of like ASP when people were putting ASP in the HTML by accident. I think that's where it came from. It behaves like a comment but renders in attributes in different versions of IE. So for example, the attribute here is HTML encoded, and if you notice, the greater than sign is closing the attribute, and then the iframe is encoded, and that will get decoded, and that mutates into an unsafe state there. So as you can see, the HTML parser is fooled because within the attribute, the greater than sign is closing the tag itself, but it still thinks it's in an attribute, so it carries on and renders the HTML. And that works in IE9. So is there like a real world example of mutation XSS? So let's do a search in Google, for example. So if we search for an ending title and then iframe and then point it to Microsoft.com, and then manually put the browser into IE8 mode, when the print preview is clicked, we get an interesting result. The title mutates within the print preview itself. So even though this is a perfectly safe string, when you do the search in Google, when you click print preview, it mutates and executes the iframe. And that's a print preview from Google. So just doing a search for that string creates the iframe in the print preview itself. So how can we simulate it? What you need to do is basically read and write in HTML. You can do that with a quick shortcut that just goes document.body.innerHTML plus equals and then a blank string, and that will mutate in HTML itself. So when it causes mutation. If you do it multiple times, you can have multiple levels of mutation. So you could have like double encoded HTML entities, and then it would be decoded multiple times after the inner HTML is read and written. So yeah, there is a tool for that. I've written a tool. You can get it at businessinfo.co.uk/labs/XSS. That will rewrite the inner HTML and give you a preview. So a couple of legacy IE bugs. You can actually manipulate anchors using a global reference to the anchor. But what happens is, so if you reference an anchor as X, like that, what happens is quite unexpected really, because when you set the variable to JavaScript URL, the anchor is href is changed. So the JavaScript URL is injected into the href attribute of the anchor. And that works in compact mode. Another trick is you can reassign functions from within the arguments of a JavaScript function call. So basically, if you've got an injection within a function call and it's an argument, you can bypass the IE XSS filter. So if your XSS occurs there, you can redefine some function to alert, and then that will execute XSS. So another bug is frame busting. So frame busters can be attacked using DOM clobbering. So DOM clobbering basically means that you can fool a JavaScript object using something else. So if you've got a form, you can overwrite references to location. So a classic frame buster is top.location does not equal self, and then self.location equals top location. So basically, if your iframe was framed, then the redirect is replaced by the parent URL. So there's a redirection from the parent URL if the site is framed. So if we can control the top object, then we can execute XSS, because if we're not actually using the top object or the self object, then we can, when it gets redirected, we can execute XSS. So form ID, for example, equals top, location equals JavaScript URL. So the injection has to occur before the frame buster in order for it to execute. Um, so in IE, the HTML attribute is decoded and the location assignment is also decoded. So we can double encode our vector. Sorry, duplicate slide. Oh, there we go. So location, so if we give the form ID a value of top and location JavaScript ampersand and then 58 alert 1, that will be decoded once as the HTML attribute. So the ampersand will be decoded, and then when the location assignment is fired, then it'll be decoded again. So we can double decode the attribute. So if the injection occurs within the X variable there, we can bypass the Chrome XSS filter, but that's by design. But if the double quote is filtered, for example, we can get a HTML version of it that bypasses the Chrome filter. So here we close the script tag, inject SVG, because we inject SVG to put the parser into HTML, so it'll decode HTML entities within the SVG script. So this will bypass the Chrome filter. The ending script will break out of the variable and then execute. So there's another way to bypass the XSS auditor. This is still unpatched. You can, if we've got an existing script block that occurs after the injection, then we can inject a script and then point it to a data URL, and then you need to concatenate the last part of the string with so the injection with the reflected output on the page, and then that will bypass the filter. That's an example. So the ABC part at the end is required because we need the closing script, because in Chrome the script requires an ending quote, an ending script tag, even though if you put a / after the script name, it still won't work. So yeah, that's how it works. IE was vulnerable to meta char set injection. Now that's patched. So it was a really simple bypass. You could just inject the char set, give it UTF-7, and then execute. But they've patched that now. They patched the HTTP equiv attribute, but they forgot that Meta can also have a char set. I think originally they did detect that, so maybe it's a regression. So IE also is blocking anchor injections. This is because if you double encode your XSS vector, inject the anchor, then when clicking on the link, you will bypass the filter and execute XSS. So the regex is really basic. It just blocks the href basically. I bypassed that using form action, but that has now been patched as well, unfortunately. So the form action basically worked by injecting a hidden element and then encoding the XSS vector, then give a button the form action name, which will point to your intended URL, well, the page that you're on, and then give it a style that covers the page, and then absolute position as well, and then clicking on the button would resubmit your hidden field back to the page, and then that would execute XSS and bypass the filter. So there's a generic method to bypass both the IE and Chrome filter. Whenever a site filters a character, you can take advantage of that to bypass both filters. IE is a bit more intelligent than Chrome in that respect, because it takes into account less than and greater than characters, and then still detects XSS even if you're injecting that within a script-based injection. So basically what we do is, if the double quote is filtered, for example, we inject the double quote within the keyword that the IE filter looks for, and then we can bypass the filter. There's an interesting part of this, is that we need to include ABC before the style injection, because otherwise the JavaScript script injection will be executed. So if we inject ABC after the single quote, that will bypass the JavaScript injection rules, so that the parenthesis won't be replaced by a hash symbol, and that will enable to execute the XSS vector. So the XSS auditor is a lot easier to bypass than IE in this particular case. So you can, using quotes works within the script injections. Using quotes with keywords, for example, in JavaScript URLs, you can inject quotes or inject any character that's filtered and bypass the JavaScript-based rules. So here's some examples. So if the site filters the parenthesis, obviously I've made a mistake there. It shouldn't be JavaScript alert because the parentheses are filtered. But if you put the parenthesis within the JavaScript keyword, that will bypass the IE filter. So if the filter filters the semicolon, we can inject that in the on-error handler there, and that will bypass both filters. And the double quote is a special case for script-based injections. If you put the double quote within the parenthesis, you can bypass the IE XSS filter. So SRC doc, that's awesome for bypassing WAFs. You can use multiple levels of decoding. So here we can use the SRC doc attribute and give it a double encoded HTML entities that create another iframe within that secure doc, SRC doc, sorry, and then the iframe will be decoded. The iframe will be decoded the second time within the SRC doc and then executed. And data URLs inherit origins on Firefox. So on every browser apart from Firefox, Firefox and IE Edge both inherit origins. We can mix URL encoding and HTML entities as well. We can also use HTML5 entities. Here's an example. So here we inject a data URL that's got a %26, which is the ampersand, which is a less than sign as well. So the URL encoded is the URL encoding is decoded, and then the HTML entity encoding is decoded too, and then that results in the iframe being executed. So another thing about URLs is that they look a lot like JavaScript. So if you look at a URL, the HTTP part is a label statement, and the / is a comment. in IE, you can actually have just a label statement for some reason, but on all other browsers, it's a syntax error. So that's valid JavaScript in IE. So if we can inject new lines, then we can execute the URL itself. Because you're inside a comment and there's a new line, then the next statement will execute your code. So IE supports both new lines and line paragraph separators within the URL. So if your URL contains a new line or a paragraph separator, then you can execute when the URL is evaled. Chrome only supports line separators. It doesn't support a new line. Firefox URL encodes. That sucks. So here's an example. Location.hash, give it a new line, alert 1, and then eval document.url. If you're inside an events handler, then you can eliminate the document dot part because within the event handler, the document is assumed. First, the element is assumed that you're looking for a property on the element, and then if you can't find the property on the element, it will then look at the document. So when you eval URL, then it'll look for eval document.url. And there's I think that's a line separator. That's how it works. We can also, if you've ever done a check for an external URL with a / and looking for backslashes, you can actually inject tabs within the /. So that will probably bypass a lot of server-side code that does that check. New lines also work. So the window on error handler is an interesting way to execute XSS. So we can execute without parenthesis. So when you assign on error, which is window.onError, assign it a function, you can throw an exception, which is then executes your code. So that will alert XSS. Unfortunately, Firefox prefixes it with 2 words when you fire it, when you're doing an eval. But Chrome uses only 1 word. So what happens is it says uncaught or something. So if you tried to eval, so what happens is you assign the on error handler to eval, you throw an exception, you give it an equal and then alert, and then the encoded parenthesis there, and then that will execute. It will execute. The eval will execute uncaught equals alert 1. And that's all I've got. Any questions? Yeah.
I'm guessing finding all of these detailed tricks and hacks takes a lot of time. Do you mostly do it like manually? You have a hunch, you're working it out step by step, or is it fuzzing? Or
There's a combination of techniques really. I do some fuzzing. I created a website called shazza.co.uk, which basically you can do shared fuzzing. So basically it works like JS performance, but for XSS vectors. So I've done a way to automate testing of like browser behavior. So like you can find like the URL example, I found that using fuzzing, but I do manual testing quite a lot as well, and even just browsing the web and finding unexplained behaviour and then trying to investigate it. That's how I found the relative URL trick. I just wondered, I was injecting a website with XSS using a forward slash and then a quote, and then I wondered why was the CSS all disappearing, and then I looked at the network, and then you could see that you get a 302, and I was wondering why would you get a 302, because it can't find the CSS, and that's how basically I discovered how to inject the CSS onto itself.
There's a follow-up question.
Yeah.
How do you detect the bad state? And how do you detect, okay, I was possibly, I did fuzzing, and in case 350, I got execution.
Yeah.
So how do you detect that? And for the other vectors, equal CSS and stuff?
So the way to check it is you can check URLs with an anchor and then inspect the host. So basically you inject some characters, so inject 2 forward slashes and then a character in the middle, and then inspect the anchor the anchor element, and then check the host is actually an external host. So there's JavaScript that actually checks where the URL is pointing to.
You're doing it in page. You're not using a headless browser or something like that, or?
No, it's using the browser, basically using Shazza to check that, and basically you can once you've got the Shazza URL, you can then basically share that with anybody, and then each of the browsers, when they're executed, will tell you which characters are being shown.
So
Yeah, sure.
most of these tricks, they are become feasible because of different prioritization of RFC by different vendors, by different browsers.
Yeah, so if there's like a behavioural difference, then there's usually a bug. So if you've got 2 browsers that do a certain thing and then another browser does something else, then there's usually a bug that you can exploit, that you can take advantage of.
So what to do, how to like make it really secure through like defining new RFC and like pushing.
Browsers are doing a pretty good job. They're basically matching each other's behaviour, and that helps quite a lot, eliminate a lot of the bugs that I find, definitely. So if they're monitoring what Chrome's doing and then replicating the same behaviour, then they'll reduce the amount of bugs that I can find. So a good example of that was Opera. So Opera allowed more properties in an external location for an iframe. Because it allowed more properties, one of those properties leaked, and then you could execute XDomain code on Opera. That was if their behaviour had matched the other browsers, they wouldn't have had that vulnerability. Yeah, sure. No, everything. It will have basically any website that has a pretty URL. So ASP. .NET is vulnerable to it as well, and PHP with the rewrite rules. But any website that prettifies URLs. You could potentially no, I'm not sure you can fix it from a server point of view. Because even if you monitor you couldn't monitor the characters within the path name, because that would probably break sites. The only probably the best fix is to use either a root relative URL, so like / whatever, or an absolute URL. Yeah.
In the relative path override thing,
Yeah.
have you found any like web languages or that would allow you to use like get variable to inject the CSS? Like if you have a reflected XSS on a beta of that RPO.
Yeah.
You understand?
Yeah. So if you've already got a vulnerability, though, you wouldn't really need the RPO, would you?
So let's say that it's a filter and you can inject stuff
You
with CSS but not like with HTML.
You could have an RPO vulnerable page that has reflected XSS. Is that what you mean? So within the URL, the URL itself would be encoded, but that would still be vulnerable to RPO.
Yeah, but I mean when it, let's say it has like index.php/files.css link, and if you give the index.php a get variable, it will echo the CSS.
Yeah.
But you can, have you found a way to make the, like the link tag when it opens, to give the style, new style a get variable?
I'm sorry, I'm not following.
Maybe,
We'll talk after. Maybe you can explain it better then. Cool. Thanks, everybody. Thanks.